Uh, Hi everyone, welcome to the course. In this video, I am going to discuss the basics from the EDC subject. First of all, just I want to write a few definitions. Electronics, EDC, electronic devices and circuits. So first of all, we have to understand what is the meaning of electronics and electronic devices and electronic circuits. So it is a field of science and engineering which deals with the motion of electrons, completely which deals with the motion of electrons due to applied external energy. That energy is due to either electrical energy or magnetical energy, or we can write a thermal energy. So due to the thermal energy or electrical energy or external energy, the movement of the electron is studied by one subject, that is electronics. So now I will write the definition here. This is the basic definition of the electronics. It is a field of science and engineering which deals with the flow of electrons due to external energy. Electronic devices. Just now explain the definition of electronics, and if any device satisfies this property, then it is called a electronic device. The simple definition: the devices which are made up of semiconductors which are used for controlling of flow of electrons. Like the field of science is deals with the motion of the electrons. So if any device satisfies this property, or if the device is designed by the semiconductor material, then it is called an electronic device. Now here I wrote a simple definition. The devices which are made up of semiconductors which are used for controlling of flow of electrons, or we can write if any device satisfies the electronics definition, then it is also called as electronic device. These electronic devices examples are diodes, transistors. Transistors means both the BJT and the FETs, right? So and any integrated circuits, so those are also comes under electronic devices only. So these are the basic examples of electronic devices. Few definitions. Now we have to discuss a few definitions from the electronic devices. So those are first of all, we'll go through the charge. Charge is denoted by Q. So it is a basic property of a conductor. It's a basic property of conductor. This charge is available in two forms. One is a positive charge and another is a negative charge. So positive or negative. But finally, the value of the charge should be 1.602 into 10 to the power of minus 19 coulombs. Here coulombs are units of the charge, and here we can write this value should be either plus or minus. Positive value indicates the positive charge and this minus symbol indicates the negative charge. Negative charges are also called as electrons and positive charges are also called as protons. Protons consist positive charge. Electrons consist negative charge. This is the basic definition of the charge. And from this, just I want to write another definition, that is current. Now current is denoted by I, which explains the flow of electrons. Flow of electrons, or we can write flow of charge carriers. If it is positive charge, write here positive charge carriers, and if it is negative charge, write here electrons. So flow of electrons is called a current. So the number of charge carriers transfers one point within 1 second. That is also one of the simple definitions. So suppose if you consider this is one conductor here, let us take this is one conductor which is connected in between A and B terminals, and here I am taking one point here. Exactly at this point, how many number of charge carriers are crosses that point within one particular time period? The time period is within the 1 second. So number of charge carriers crosses one point within 1 second is called a current. That's why we can write up the current definition from mathematical equation is from this definition, that is a dq by dt. dq by dt, that means the rate of change of charge with respect to time. So the time rate of charge is called a current, or we can write simple definition is charge by time. So charge units are coulombs and time units are seconds. So 1 coulomb for 1 second is also called as a 1 ampere. 1 coulomb for 1 second is also called as 1 ampere. So now onwards we have to take the units of the current should be amperes. And similarly, now I am writing another simple parameter, that is a voltage. It is also one of the electronic parameter, voltage. The work done by charge. Just now I explained the flow of charge carriers is nothing but current. So if the carriers are moved from one place to another place is called a current. To move the carriers from one place to another place, it requires some external force. That force is called a voltage. It is also called as EMF, electromotive force. So the simple definition we can write here, the work done by charge. Work done by charge, which is denoted by V here. So we can write like this, dW by dQ, work done by charge. Work done units are joules and the charge units are coulombs. So 1 joule for 1 coulomb is also called as volts. So now onwards we can write the units of voltage is a volts. And voltage and EMF both are same parameters. So voltage means we have to take the potential difference between the 2 points and EMF is nothing but the external force. Both are same parameters. If you take this voltage as an independent variable, then it is called a EMF. And if it acts as a dependent variable, then it is called a voltage. Voltage, or we can write potential difference also. And from this here I am writing some other internal parameters. So that is electric field intensity. Electric field intensity denoted by capital E. Capital E. So this parameter is also one of the basic field theory parameter, which gives the ratio of the voltage and length. Voltage to the length. Or we can write the force acting on a unit positive charge. Or we can write one more definition, it is the ratio of voltage to the length. So from this we can write like this, the electric field intensity is the force acting on a unit positive charge. So we can write V by F is a force here, force by charge. So units are force units newtons per coulombs. This is one definition. Or we can write this electric field intensity is voltage by length. Voltage by length. The voltage applied to any one material with a particular length L. So the voltage units are volts and length units are meters. So we can write volt for meter. This is also one of the units of electric field intensity. So finally, we can write the units are here newtons for coulombs or volt for meter. These are the units of electric field intensity. Now here we have to consider another parameter, that is a current density. Current density denoted by capital J. It is the ratio of current to the area. So it is the ratio of current to the area. So that is a current I by area, we can write like this. And units of current amperes and the units of area meter square. So the units of current density is ampere for meter square. So the number of carriers transferring through one conductor, the conductor consists particular area. So that charge carriers passes through that area is explained by the current density. So current density denoted by capital J and units are ampere for meter square. So just now I explained all the basic parameters which are used in electronic circuits or electrical circuits.